Welcome to our revision questions integral calculus, and we continue from where we left last time. We had begun on doing revision questions. So today we're looking at this question 1, 2, 3, and 4, and then part of question 4 will be left for you as an assignment so that you try it later. Let's begin with question 1. In question 1, we're integrating x plus 1 over x squared into x minus 1, the x from 2 to 3. Now this we shall do this by use of partial fractions. Shall resolve our fraction into partial fractions. So what I mean by this is that we would have, just a minute, let me do it from here. We would have x plus 1 out of x squared into x minus 1 written as a over x plus b over x squared plus c over x minus 1. So on our right hand side, we put it under the same denominator, and the LCM here is x squared into x minus 1. X would go here, x into x minus 1 times. So I would have a x into x minus 1, and then b, x squared would go here, x minus 1 times x minus 1, and then plus c, and x minus 1 will go here, x squared times. So I would have minus c x squared at this point. What follows is that we equate the numerators. So equating the numerators, on our left side we have x plus 1, and on our right side we have ax into x minus 1 plus b into x minus 1 plus c x squared. Now what I'm supposed to do at this point is to get the value of x, now the value of a, b, and c. So to get the value of a, b, and c, I can begin by finding the value of c. Can I begin by finding the value of c? So for me to find the value of c, I need x to be 1. Just a minute. So I need x to be 1. So when x is 1, what happens on my left side? In fact, on the right side, when x is 1, you discover that this bracket, whatever is in the bracket, will become 1. So the whole thing will be 1 here. And again, at this point, whatever is in the bracket will be 0. This will be 0. So the whole thing will be 0. This will also be 0, but the whole thing will be 0. So when x is 1, on the left side we'll have 2, and on our right side this is 0. So the whole of this is 0. This is also 0. So the whole of this is 0. X is 1. This will be 1 square, which is 1. So C is 2. C becomes 2. Let me find B. To find B, I only need to equate x to 0. So when x is 0, I don't know why x is writing itself in a funny way. Yeah, when x is 0, what we realize that this point will be 0. This is 0 times a, so this becomes 0, and so the whole of this will be 0. And again, x is 0, so c times 0. The whole of this again will be 0. So what happens to the left side? The left side becomes 1, because x is 0, so it's 1. So this part is 0. This part is also 0. And so I can have negative b. Or I would have that b is negative 1. B is negative 1. Now, so I'm left with a to get. I need to get a. I have b, I have c. So to get b, to get a, I'm seeing that the easier way to do this would be to expand this right side. Expand this right side. And then substitute the value of c and the value of b. So let's just write what we have. What we have is x. On our left side, x plus 1. And then the right side, I have ax squared minus ax plus bx, but b is negative 1. You just use it straight away. B is negative 1, so I put negative 1 where there's b here. I would have negative x, and then negative 1 times this negative 1, I would have positive 1. And then c is 2. 2x squared. Now, so what I discover is that the left side we have a value with the x, and then we have the constant. The right side we have the value with the x squared. I have x, then the constant 1. So 1 is equals to 1. But I need to equate the values of x. So I have x, the left side, equals to the right side, I have negative ax from negative x. So which means that I have x equals to, what is wrong with this x? X equals to x into negative a minus 1. So x would cancel out, and we have 1 equals to negative a negative 1. Or that a is negative 2. So a becomes negative 2. So we now have the value of c, the value of b, and the value of a. So you can go back to our equation here and substitute them and then integrate. So we need to substitute them in this equation and then integrate. So let's just do it here. I can delete this part. I can delete this part here. But I can use it. I can delete this part so that I use it. It's okay. Let's now do that. So that means that the integral of x plus 1 over x squared into x minus 1 is the same as the integral. A was negative 2 over x dx plus the integral. What was b? B was negative 1 x squared dx, and then c was 2. As I mean, let me erase this so that I write correct c. So this is negative 1 dx. Yeah, A was negative 2, B was negative 1, and C was 2. So I can also erase this other part that will use it. Okay. Now let's remember our limits. Our limits were from 2 to 3. So you can put there our limits 2 to 3, 2 to 3, 2 to 3, 2 to 3, and then 2 to 3. We can now integrate this. This one is very easy. Now we shall put the limits on the final integral. So integrating this, I will negative 2 ln of x, ln of x. But then what about this? This one you can write it as x raised negative 2. X raised negative 2. So you know that when we're integrating this, we are adding 1 to the power and then dividing by the new power. So when I add 1 to the power, I would have x raised to negative 1 and then divided by negative 1. So you see that this negative with this negative will give me positive. So positive x raised negative 1. And then this one will be 2 ln of x minus 1. There is no need of putting the concept of integration because we are dealing with a definite integral. So we just put our limits. This equals to, now so let's just put our limits. When I put 3, I would have 2 in ln of 3, ln of 3 plus 1 over 3, and then plus 2 ln of, now 3 minus 1 is 2, then minus, now put in the lower limits, we would have negative 2 ln of 2 plus 1 out of 2, then plus 2 ln of, this is 2 minus 1, which is just 1. Now this one you can do it on your calculator. And I did it on a calculator, I was getting 0.40869 and then 747. Now, I don't know, the question wants us to find the answer to some number of decimal places. No, there are no decimal places specified. So just give the answer as it is. Okay, let's look at the next question. We create some space here. Now the next question, enlarge this a bit. We're supposed to integrate elements. Now this one is supposed to integrate. Next question says that we find the integral of sine raised to 2t cos raised to 4t dt, and the limits are from 0 to pi. The good thing about this kind of questions when you're integrating trigonometric ratios is that you're supposed to first of all check the powers and see whether they're even or odd. In this case, the exponent for sine is even, and therefore cos is also even. So we do it differently from the way we did in our previous video when we had the exponents that were odd. So these ones are even. So when the exponents are even, we need to recall the following from our trigonometric lessons. We recall that sine square t or x will be the same as a half into 1 minus cos 2t. And we also recall that cos square t is a half into 1 plus cos 2t. So you must recall this. This is from trigonometry. But if it were odd, if the exponents were odd, then we do it. We don't need to recall this. So now doing our integration, we must write the integral in this form. Must write it in this form. So what we have as our integral is the integral from 0 to pi of sine square t cos square t square dt. This is same as, I want to just substitute this. This is same as the integral from 0 to pi. From 0 to pi, instead of sine square t, I'm writing a half into 1 minus cos 2t. And instead of this cos square t, I'm writing a half into bracket cos 2t. No, it's not. This is a 1 plus that. Or I should just have said plus. Okay, 1 plus cos 2t. Then I'm squaring the whole thing dt. Now, doing this, I would have the integral from 0 to pi. You notice that a half square would be a quarter. That a quarter times this would be 1 over 8. So I just want to take them outside the integral sign from this beginning. And so that I'm left with 1 minus cos of 2t multiplied by 1 plus cos 2t cos 2t, and then I square it dt. So we just need to expand this first. Expand it. Let's just expand this. Need enough space. That's okay. So I would have 1 over 8, the integral from 0 to pi of 1 minus cos of 2t multiplied by, let me expand this, and doing that I would have 1 plus 2 cos of 2t, and then plus cos square 2t dt. So you now to expand this, just 1 times itself gives you 1, 1 times cos 2t gives you cos 2t, then 1 again plus cos 2t. So that sum gives me 2 cos 2t. Then this one gives me that. So I would have 1 over 8, the integral from 0 to pi of, now expanding this, I have 1. This times that, I have 2 cos, that was it. This times that, I have 2 cos 2t. 1 times that, I have cos square 2t, cos square 2t. Then I have this negative cos 2t times the whole of this, which gives me negative cos 2t. This cos, what is it? Cos 2t. This one times that is negative. Then this times that is minus 2 cos square 2t. Yes, this times that I have a negative 2 cos square 2t, and then this times that I have negative cos cubed 2t dt. Can look for the like terms and collect them together. So this will be 1 over 8, the integral from 0 to pi 1 has no like terms, so I just put it there. I have this 2 cos 2t and this negative cos 2t would give me cos 2t. So I'm done with this and that. And then I have this cos square 2t and this 2 cos square 2t will give me negative cos square 2t. So I'm also done with this and that. And then I have negative cos cubed 2t dt. Recall what we said from the start. We already said that cos square t the same as a half into 1 plus cos 2t. We already said that. So that we shall use this to substitute this. Because if this is the case, then we also know that cos square 2t would be a half into 1 plus cos square cos 40, not square. So if this equals that, then this will be equals this. So it's this, in fact, that we shall substitute here. And then this one we shall write it in terms of sign. So what do we then get? What we get is 1 over 8, the integral from 0 to pi of 1 plus cos 2t negative. Instead of this, we have a half into 1 plus cos 40. And then instead of this, let's write cos 2t into 1 minus sine square 2t, because of the other identity that says sine square theta plus cos square theta is equals to 1. So because of that identity, then I have this. So again, simplifying this, I would have 1 over 8, the integral from 0 to pi. There's this 1 and there's this half. Is this 1 and this a half, giving me a half, plus there's this cos 2t and this other negative cos 2t, they cancel. This negative cos 2t, they cancel. And this is cos 2t. See, this cos 2t. Okay. Now remember that there was a half, we already used it. Then what we are left with is a half cos 40. So we are done with this, and then the whole of this. We're also done with this part here. So we are left with this and that, which will give us plus cos 2t sine square 2t dt. We are now ready to integrate, but we must change something here. Must change this. You cannot integrate it this way. So you must recall that from the start we said sine square t. So if this one is 2, then we would have a half into 1 minus cos 40. We would have that. So again, let's just substitute that. So what we then have would be what we then have will be 1 over 8 into the integral from 0 to pi over half plus a half cos 40. Then this is this one is cos 2t into 1 minus cos. Now this one you don't even need to change. You don't need to change this. You don't need to change this. You can just integrate it there, the way it is. You can just integrate it the way it is. This one can be integrated. So let's just integrate now. Let's just integrate. This will be 1 over 8. We are now integrating into, with respect to t, this will be a half t. This will be a half t. And this will be 1 over 8 sine of 40. 1 over 8 sine of 40. But this one, how we integrate it, you just need to say that let u be sine of t. Let u be sine of t, so that the u will be negative cos t. This is 2. Let's just have it that way. It will be du is equals to cos t dt, or dt is du over negative cos of t. So that if I'm integrating cos this is 2 here. So let's say that this one will be 2t. This one will be 2t, so that this one becomes 2, negative 2 cos 2t. And so that this one is negative 2 cos 2t. That's now okay. That's now okay. So that if I'm integrating cos 2t multiplied by this, instead of this, I'm writing u. So this I'm writing u square. And instead of dt, I'm writing du over negative 2 cos 2t. So that cos 2t cancels with cos 2t. What I have is negative a half integral of u square du, which is negative 1 over 6. Negative, we see this is 3 here. I add 1, it becomes 3, divided by 3. So I've got u cubed, but u is sine. U is sine, so sine cubed 2t. So this becomes the integral of this. The integral of this, so it's negative 1 over 6 sine raised to 3 2t. Our limits are from 0 to pi. So we can now put our limits and see what we get. 1 over 8 into, just put pi, half pi plus 1 over 8 sine 4 pi minus 1 over 6 sine 2 pi cubed, then minus, if I put 0, I would have 0. So this one can be done in a calculator. You can do that on a calculator. And see what you get. But that's how it is. That's how it's done. That's how it's done. Let's check and see. I'm seeing that this sign here is supposed to be negative. Let's see where we lost it. It's here. It's here at this point. This point, remember, this was giving us a half, and then this was cancelling with this one here. But at this point, this was supposed to be, this is supposed to be half negative. It's supposed to be negative. This one here is supposed to be negative. So the same thing here. The same thing here. And then here. So this is supposed to be negative. This is supposed to be negative. Then you use your calculator. Okay, let's look at the other. Let's look at the other example. Find the area. Find the area of region R, which is bounded by our region R is bounded by y equals to e raised to x, and then bounded by lines x equals to ln of a half and x equals to 0, and then x-axis. So we need to find the area bounded by those. I'm trying to enlarge this, but seems it's not enlarging itself. But that is a question. We need the area of region R, which is bounded by this curve, and then this line, this line, this line. Now, if you try ln of a half, you find that it will be negative. This will be negative, and there's this. So what we have then, our curve, if I was to sketch it, our curve would be something like this. Our curve will be something like that. This is our y is equals to e raised to x, and then this is the line. This is a line x equals to ln of a half, and this is the line x equals to 0. So our region is this. This is our region. So how do you find area? Area, therefore, will be given by the integral from, our lower limit therefore is ln of a half, our upper limit is 0, and we are integrating e raised to x dx. Now, so this would give us e raised to x there's no need of putting the concept of integration. So let's just remember that we are doing it from ln of a half to 0. Ln of a half to 0. So if I were to put the 0, limit to 0, I'll get 1, then minus e raised to ln of a half, which is a half. So what I have is 1 minus a half, and this is same as a half. The answer is a half. So the answer to that question is a half. So our third equation, we create space for the third equation. Now, so the third equation says, yeah, we can now enlarge. It's now okay. Enlarge it. And enlarge so that if you had not seen the other questions, you can now see them. Okay, it's now okay. It's visible. Now, find the area of region A. Now, the area of region A bounded by this and this is rotated about 360 degrees. That's one revolution about x-axis. Find the volume. This is the volume of revolution. So when you rotate, when it goes one revolution, what is the volume? That's a question. And remember that in this kind of questions of revolution or volume of revolution, we have a formula when we get in it. When the solid is rotated about y-axis and when it's rotated about x-axis. So you need to know, are we rotating it about x or is it about y-axis? Now if you are rotating it about x-axis, one revolution, the volume will be given by the integral a to b, with these are the limits, of pi y square dx. This is a volume of rotating a solid around x-axis one revolution. So doing that, we've been told our limits. Our limits are 1 to 4, so we're doing it 1 to 4, and x square plus 4 square. Let's not forget pi. Let's not forget pi and the dx. So when you do this, well, let's just expand that, and we are integrating from 1 to 4. Expanding this will give us x raised to 4 x raised to 4. This times that, and then twice it will be 8 x raised to 2 plus 16. Let's just put pi outside because it's a constant, dx, and integrate that. Let's just clear this space. So when you do this, we'll get pi into x raised to 5 over 5 plus 8 over 3 x raised to 3 plus 16x, and the limits are from 1 to 4. Just do that on your calculator and see what you get. Let's do that on your calculator. I was getting 420.6 pi. That is the volume. 420 over 6 pi. Now the other question, I want to use Simpson's rule. Is again get space for that. Just get space at this point. Just get space at this point. Because we need a space for the table. Also, the equation that we're given is the integral from 0 to 8 of root x dx. So we've been taught to use 4 intervals. So 8 minus 0 divided by 4 will give us height, the width of each interval. And so this is 2. This gives us 2. So that means we need x0, 2, 4, 6, 8, and then what would be root 2, root x. So that one can just use your calculator, and root the square root of 0 will be what? The square root of 2, let's do it to 6 decimal places, there's no problem. I was getting 1. This one I was getting 1.414. And this one is, of course, is 2. This one I was getting again a longer value. I was getting 2.44, 94, 90. And then lastly, the root of 8 is 2.8, 28427. So we have those values. Then we go straight to our formula. And the formula for getting area using Simpson's rule would be a third into width. Our width is 2 multiplied by the first ordinate plus the last ordinate, first plus last ordinates, then plus 4 multiplied by the even ordinates, then plus 2 multiplied by the remaining odd ones, ordinates. That is the formula. So this will give us a third multiplied by 2 into bracket. The first is 0 and the last is that. So that sum will give us 2.828427. then plus 4 into the even ones. This is odd, this is even, and this is the other even. 1, 2, 3, 4. So this is even. 1 plus 4, 1, 4, 2, 1, 4. Then this other one is 2, 4, 4, 9, 4, 9. Then plus 2 into the remaining odd ones. Just clear this so that we don't mix them. Just a minute. Okay. The odd one that is left, this was odd, even, odd. So this is the only one that is left. So when you do this with your calculator, you would get 14.8554 when you do this with your calculator. Remember that this bracket is closed here. Good. Now what follows is some exercise for you. So let me give you some questions so that you use the examples I've shown and you do the questions here. I just want them to be visible. So the questions are here. You try this. So you just be using what I've already done. The first one, find the area of the region bounded by this, and that. So this one you've already done it. So I just use my example there. Then this one you're getting volume, and the solid is rotated about x-axis, just as the one we did. And then this one is the only different one, because this one we are using the mean value theorem, but it's not hard. And then this one you're using the Simpson's rule, we just done. But apart from that, I also want you to try this. But this one is just integrating now. Now you may want to try and see whether you can apply other formulas other than substitution. Try and see whether you can do it by parts or any other formula. Let me just make it visible. The last one is not very visible. Just a minute. I have to, if I make it visible, I have to erase something here. I have to erase this, the ones I've just added. Yes, can now be enlarged. Yes, I wanted to look at these last ones, these last two. They are all here. So you try this exercise and see what you get. Otherwise, thank you.